Hello, my name is Greg Sweeney. I work for Modular Mining Systems, which is based in Tucson, USA. It's part of the Komatsu group of companies, and we specialise in producing fleet optimisation products for the worldwide mining industry. My role is to look after the Asian region, so I look after countries including Taiwan and throughout Asia as well. What modular mining is all about is increasing the efficiency of mining operations. So we take a typical mine is totally disjointed and does not have a coordination, and what our system does is applies a level of coordination and control over that mining operation. The way that we do that is we install a number of systems. So I'm not sure whether you can see this, but we can cut that in later. Is we install a wireless network in the entire mine, a wireless LAN that we supply. We then install inside each vehicle one of these computers, which are supplied by D-Log of Germany, who of course D-Log are part of the Advantech group of companies. We use the wireless network to send data from these mobile computers to a central control room. So in the central control room they have a bird's eye view of the whole operation. So they're seeing at all times the location of all trucks, what items they're carrying, what quantities they're producing, etc. And using our software, we're able to optimise the production of that operation in real time. So on board the trucks is the computer. This computer has a GPS and a radio antenna. It's also interfacing with onboard systems. So a lot of these large trucks have a lot of onboard computers. So we're interfacing directly with those, such as engine management, payload management. And all that data is sent back to the control room in real time. It's probably similar to like a dispatch system in a taxi. So in a taxi they'll have a screen in front of them, and then on that screen it advises them of their next job, what their next task is. That's what this software is basically doing. It's looking at a bird's eye view, a holistic view of the operation, and advising the trucks in real time as to what their next operation should be. So instead of the truck going back to a particular excavator that perhaps is broken down for maintenance purposes, the system will send the truck to a different excavator. The idea being that you can increase your productivity of your operation by at least 10%, sometimes even more depending on the operation. So it does many other things other than just a dispatching operation. We're also looking at the safety of the vehicles. We understand the speed the trucks are travelling because of the GPS tracking. We understand the fatigue of the operators because we integrate certain systems to manage their fatigue. We're able to manage the tyres of an operation. If you consider these tyres are all in excess of $20,000 each, you want to do everything you can to minimise the tyre wear and tyre blowout. So what our system will do is help you manage the risks associated with tyre damage. We also help with the refuelling of these trucks. As you can imagine, in a large operation, you have sometimes more than $1 billion invested in an operation. You want to maximise the amount of production that these things can produce. So we're looking at all aspects, including fueling and the shift change, to optimise the maximum amount of production from that operation. So one of the key things that the operation is able to benefit from is not only maximising their production, but also to record all production. They receive all data about by grade, what type of quantities have been produced, how much overburn has been produced, what the flow rate through the crusher, for example, is. So all these different aspects are all captured in real time and stored in an SQL database. By using this data, the operation is then able to go through a process of continuous improvement. So you receive the data during the shift, which is all well and good to optimise that shift, but that data is available in the database for ongoing improvements in the operation. So you can look at the strategies to greatly increase your production in subsequent shifts as well. So as I was saying, in terms of installing the system, the first thing that we do is we put a wireless network into the operation, which gives 100% coverage throughout the entire operation. On board the mobile trucks, we install the D-Log computer, which is supplied through Advantech. That computer on board is interfacing with onboard systems, onboard computers upon the truck. And we also install with the computer a GPS and a radio antenna. So in real time, the data is being transmitted via the wireless network back to a central control room. So what you then have is, instead of having a disjointed, uncoordinated mine, every piece of equipment in the operation that has a computer installed is now recorded in the central control room and shows up on the central software in terms of optimizing the production. The central software then has special software loaded that makes analysis of all the data coming in and then sends messages to the trucks about the best allocation of their time. So it's optimizing the use of the equipment by having a bird's eye view of the operation. So it's sort of similar to like a taxi dispatching operation. It's knowing where everything is, what their next availability is, and then making a decision as to what the next action should be. All that data is also available on the LAN of the mining operation, so it can be used for producing many different types of reports, etc. So what we're trying to do is go from an operation where there's many different paths, many different outcomes, and searching for the most efficient, most effective use of the resources at any point of time. Here's an example of what the central server software looks like. It's showing like an LP route, which is indicating which trucks are allocated to which shovels, and the software in the background is making recommendations as to what the next action should be for each truck, which would be the most efficient outcome. Here's another view of the central software, which is called Mine View, which shows the layout of the mine based on all computer dot traces. So you don't need to see the mine to be able to use our system. In fact, most mines don't see the operation. They're in a office in the back office there somewhere, and they're using the screens to give them the information about the mine. So, due to having GPS, we're able to capture every part of the truck and shovel cycle. So this records automatically what each piece of equipment is doing at what time and changes it to the next status as soon as it changes its GPS location. This is an example of what the truck screen looks like, the small D-Log screen that's installed inside the trucks. We configure this to suit whatever type of truck it is. And the operator receives different instructions on board this computer, and he's able to also change his actions and statuses to give information back to the control room as well. Here's another example of the status changes. So the operator can hit, for example, that he's on delay or standby, and then he can have a reason code as to why he's on delay or standby. That's a key part of any mining operation, is understanding what the availability of the equipment is and what the utilisation of that equipment is within that availability. One of the key things about using a system is to use the data to optimise your production. So this is a real life example from an African mine, which clearly showed the differences in loading times for excavator operators using the same equipment. So some excavator operators were taking 3 minutes, others were taking more than 6 minutes. So by simply retraining some of these operators to achieve the best benchmark levels, they were able to improve their productivity by more than 5.7%. Here's another example of what our data can help you with. This is a payload analysis for an actual mine. It shows that this mine is actually underloading on average by 10%. So they're wasting 10% of their carrying capacity in the mining operation. So with a few simple changes in procedures, this mine was able to increase their output by 10%, which is a significant increase considering that they spent no additional money. Module is a worldwide company. We have offices all over the world. Our corporate office is in Tucson in the USA. We have a number of offices in South America and North America, including Canada, an African office in Johannesburg, Moscow office, an Indonesian office, a Chinese office in Beijing, and I come from the office here in Australia. We can also integrate other technologies such as cameras. We can use the system for generating proximity warnings, etc. So as you can see here, we've got, no, that's about it. I've flipped over too far. So this is the PTX unit that we sourced from D-Log in Germany, and As you know, DLoG is now part of the Advantech group. This is being designed in conjunction with modular to suit our application. One of the reasons why we purchased this unit was its toughness. The mining operation is extremely a difficult environment, and I believe that this particular unit was designed to a higher G level or higher shock level than any other previously built unit by DLoG. So in a mining operation you have a lot of problem with vibration, with heat, with dust, with cold, all those different things come into play. So when we design a system, we'll design it to suit what the customer is looking for, but a truck setup is different to a excavator setup, but it's different again to a water truck setup. So it's the design is to suit the particular application. So the operator receives instructions on here as to what his next task is, and that information is coming from the central control room. The central control room has a holistic bird's eye view of the operation and is making allocations of each truck to the most efficient point. The operator can also just touch the button and do various functions as well.